All right. So, well, first of all, yeah, thank you for the patience. I see the screen is flickering a bit. I don't know if it's only on my side. If not, I can continue. But yeah, so yeah, my name is Oswaldo Gomez. I am a lead IT expert at Roche. I've been working in MLOps before basically the kind of the name existed for like maybe like 4 or 5 years now. I used to work in the finance industry in S&P Global ratings, and yeah, I remember pitching Kubeflow inside of S&P Global, and I do remember very clearly how they said like, well, this thing about machine learning operations, I don't think it's gonna catch up. Like, why do you really need? I don't think we really need to be like that much structure when it comes to machine learning, and that one didn't age very well. But that right now, I was offered a position, and I moved to Poland like through almost 3 years ago. And the reason was because they were using Kubeflow, and yeah, I mean, this is one of the questions I ask the interviewers when they offered me the MLOps position, and also the fact that they were offering an MLOps position, like that just resonated with me that this company was going in the right direction. But let me just tell you a little bit about us. I have promised just one slide, and we are, a 125-year-old company, and we are actually one of the biggest companies in the world across industries that spends the most amount in research and development. So I was shocked when I heard this when I joined, and yeah, it's because making drugs is extremely expensive and time consuming. Takes about $1 billion and about billion with a B as in boy, and then it takes also about 10 years to make one drug. So it takes a lot of time, and there's a lot of R&D, and this translates as well into informatics. So now we are in something called Roche Informatics that was basically conceived very recently, and we focus on delivering technology that helps, evolve the practice of medicine and also help patients live longer, better lives. And as you can see, I'm in Poznan at the top of the screen, basically, and we have offices across the world, but the informatics division is in San Francisco, Madrid, Poznan, Warsaw, and Basel, and then of course Kuala Lumpur as well. So this is Roche, but yeah, let's go to the next slide. I wanted to make it because one of the things I heard you say earlier was that why is it so difficult? And yeah, it's difficult to use Kubeflow because we are doing very complex stuff. So the purpose of this talk is to try to simplify a bit, what it means to make machine learning operations. And I wanted to like shine a bit of light and make a demo that I will not be able to show on a couple of technologies that go together very well with Kubeflow. But just I have a slide about MLOps that I love, which is this one. So MLOps, I know we are, a community of experts in this area, but I always find that it's good to just go back to basics and talk about like from a high level what we are doing. I mean, this is MLOps, and I really like this slide because at the bottom you see code and at the top you see data. And if you think about why MLOps is so difficult, it's because we are dealing with data. And if you have let's say a perfect code that you hire the best engineers in the world and you make some software package that just ages very well, there's no bugs, and it can actually run for a very long time. And yeah, and that's it. That's DevOps, CI/CD pipelines, and all of these things help you make sure that you have maintainable code and all good. However, even if you have perfect code and the data, or in this case, the world changes, like for example, during COVID, all the machine learning models that were
recording in progress.
Oh, can you hear me? I started hearing like echoing noises. All right. I will continue. I hope everything is okay. Just heard a bit of echo, but yeah, if you think about it, of course, if the world changes or the data changes, the machine learning models that you have trained, even on the perfect data set, will all of a sudden like become outdated, sometimes immediately. And this is when you need to start thinking about MLOps. And yeah, we can go to the next slide. Thank you. So, however, building an MLOps team, it's very complex. It's difficult because you need either an MLOps engineer that knows a little bit of everything that is here, like data science. You need to know data engineering, software engineering, DevOps engineering, and backend engineering. And when I say backend engineering, of course, I mean Kubeflow and Kubernetes. And this is very hard. Like, you think about it, like finding people on any one of these bullets, it's difficult. But of
Recording in
course,
progress.
you might have to find a team, and if that is your task, I would advise, based on my years of experience in MLOps, like try to grab not like 5 data scientists and a single backend engineer. That probably will not age very well. It will be hard for this backend engineer to convince about best practices and whatnot. So yeah. Oh, now you see me a bit better. So yeah, now we can go to the next slide. Also, a final slide about like kind of MLOps a bit theory. I love this slide because nowadays there's lots of books about MLOps. And before, like a couple of years ago, there was basically nothing, only like Google maturity levels, and that's all. But yeah, this yeah, this slide is pretty cool. In my opinion, it reflects it puts in the center the high quality code and DevOps. And also, like if you at the top of the pyramid you have MLOps, and this is the Maslow pyramid of needs. And this is an analogy from the human Maslow pyramid of needs, where at the very bottom you have like food and shelter, and at the very top you have like your full realization of yourself, and your full potential at the very top. So to get to full potential in machine learning, you need high quality code and DevOps. And I really presented this slide last week on our DevOps days here at Roche. And I think it resonated with DevOps engineers that have nothing to do with ML, but that I try to like demystify what it means to be an MLOps engineer. Then data automation. So you need to make sure that you have a way to get data and send predictions somewhere automatically. No, like CSV file that you download and you upload somewhere, like that wouldn't work. And platform automation and MLOps, platform automation to me is like make sure that Kubeflow runs well. If Kubeflow runs well, then you have this platform that you can. We already have hundreds of models in production, and thanks to Kubeflow, we have like a very big amount of users that inside of our company. We are more than 100,000 employees, so you can imagine there's multiple groups that are using Kubeflow. And yeah, if you have all these things combined, at the very top you can achieve MLOps. And yeah, on the side we have some things about like make sure you can. So Jupyter notebooks need to move into manageable functional code components. And if you think about it, this is, well, first of all, Kubeflow has notebooks that you can like harden and make sure that they work. But then moving into functional components is so that eventually this Jupyter notebook turns into a Kubeflow pipeline. And this is where we are trying to help the data scientists navigate. And then, of course, you need reproducibility. You need to be able to manage your environment dependencies and then focus on pipelines built on ML platforms. So this is also what you should be focusing on, and test as much as you can, right? You need to test the data, you need to test the code, make some smoke tests, the machine learning infrastructure. Like Josh mentioned, it's hard, but it's because what we do is also complex. My aim here was to show you something that I'm going to have to like just talk about it. But if you can please go to the next slide, I will try to oversimplify what it looks like to make it all the way to production with Kubeflow, and just taking as the center a Git flow. Like normal, like if you put Git and basically the MLOps platform being Kubeflow. This is also another slide I took from one of the books I've been reading, and it makes a lot of sense. So you start in a development environment. This is actually similar to what we have in my team. We have dev, UAT, and production Kubeflow clusters, and so you make some changes and then you commit the code. Then you want to maybe do some training and testing, and then you deploy to test. Then if you're happy, you're satisfied, you can then move to staging. And then here you can run some static and unit tests, then run some data preparation training, deploy test. And then from there, you can move to the right and then, make some reports, you have some manual approval, and you can, create a new tag. And then if you're very happy, you can move to production, you create a pull request master, and this yellow business validation in Canary, this is basically what KServe offers out of the box, and it's very, very nice. So KServe, it gives you this ability. This was part of the demo, essentially how you can go from like machine learning code to Canary deployment, which is somewhat advanced if you think about it from like, for a data scientist. And then you can have some manual approval and have a rolling upgrade, which also KServe and Knative, under the hood, and Kubernetes and Kubeflow help you achieve. And now, please, let's go to the next slide. So I maybe a good way to show that this is not something that it's very. If it was extremely complex or impossible to scale, then we wouldn't have all these teams at Roche, which is to me like a microcosmos of the world. No, we have people across the world. We have different teams, different line managers, different business, but we are all trying to help patients, right? That's our goal. But we're all deploying Kubeflow in different ways because we have an AWS EKS, which provide our infrastructure, but on top, each team decided to deploy Kubeflow in a different way, and we have people using all are using GitOps, but some are using like different technologies, maybe customized, maybe Helm, and this is not like maybe scaling well internally. So we finally came together and decided to join forces, all of us. And for the first time, we are working together to make sure we have one single way of deploying Kubeflow internally, which, we have a lot of internal discussions about why will we do that, because we have the manifest working group doing that for the world, and this is a great job. But of course, some of these components that come out of the box are not like production grade, like Minayo or, for example, MySQL that comes inside of a pod. So all these little pieces are what make Kubeflow like production grade, and we are all doing it a bit differently. So we are unifying that, and we are very happy that this shows basically the trust that we have in this technology, and we really enjoy. And if you scroll one more, please. So we are internally organizing ourselves into like an inner source Kubeflow structure. So we were kind of, sorry, the next slide. I don't know if you moved it, but I can still see the last one. Yeah. So we are in our infancy right now. We are organizing ourselves. We're mimicking what we see from the outside. We're creating an inner source culture. We have one working group. We're trying to deploy it in a very specific way. We have a lot of ideas. We have another one of my colleagues actually talking a bit later about some of his contributions to Kubeflow, that he has a pull request open or merge request. So we are actively, also trying to take this knowledge that we are gathering internally in different places and bring it eventually back to the community. And just wanted to show already a bit about the impact that we already have. And if you please go to the next slide. Even though Roche is quite large and we have many different groups, particularly one of the groups is Pyramid MLOps, which I've been working with for more than 2.5 years. And we are together. We have different roles, different responsibilities. We have on the right side scientists, on the left side scientists, in the middle the developer team, and we have different skill sets, and we all complement each other to make this work. And when you combine these multidisciplinary groups, if you can please go to the next slide. This is the impact that we already have. So we have more than 150 predictors. We have impacted more than 8 business cases. We generate millions of predictions on a monthly basis, and we have 12 data products and expert systems integrated. So what are we doing at Roche? So we predict large molecule properties, and we use it to plan experiments. So it's not the same to imagine how many molecules there are in the world. Like, I mean, there are literally like billions of molecules, and if you can eliminate just a small percentage of them using AI, then it can save lots of time. And if it saves not only money but time, these medicines can get to the patients faster. So that really motivates me to do it well, to make sure that we have a good solution. Then we use it to classify microscopy images and select cell lines, and also to label news and scientific articles and alert users. And even if it's not here, we have obviously large language models that people are immediately like jumping to us and asking us like, wait, can we use this? Can we actually use this model and that model and that? And we say, of course, just yeah, what do you need it for? We just take a step back and say, do you really need a large language model? And if they really need it, we Kubeflow is there, KServe is there, and it's great, great combination. And however, my demo, which is now a bit ruined, I wanted to show you how you can start from a simple machine learning code, like a couple of lines of Python code, and go all the way to like a KServe inference endpoint where you have like rolling updates, where you have scale to zero, like great. And this is very common, right? Everybody's doing this, but I really got inspired by looking at KServe documentation. So if you can go to the next slide, this is where I kind of found that this tool, like we already knew it was there, but Knative Buildpacks is just something that I think it has the potential to simplify what's anyways complex, but make it less. So data scientists in my organization are bioinformaticians that have gone through PhD, postdoc, and then they work in a lab for many years, and then sometime in the future they get hired. So we really don't want them to learn Docker. I mean, there is no value. They are a very valuable assets and very obviously expensive assets to have, and we don't want to, for them to start learning Docker from scratch and okay, please write a Docker file, like and expect that it's going to be done in a secure way. Like it doesn't make any sense. So what we have been using is cloud native Buildpacks for building packaging R without a Docker file. So you grab the Python file and you create a Docker image, and then the demo was going to show exactly then that you have the Docker image, you plug it into the KServe, and then you have a fully deployed inference service that has all these features. If you deployed KServe with Knative, then you really have a lot of power, and then you didn't have to go through Docker. And probably this brings a lot more work for us, the ops team, but we don't care. Like we want the data scientists to have the simplest journey, and we even call it exactly that. So yeah, what happens here? So the build pack is kind of like automatically building a Docker file. But what it's doing is that there's like 4 stages. There's a detection. There is that automatically determines which build packs are required to build the application. And this is actually quite interesting because officially there is no support for R. And in bioinformatics, R happens to be very popular. And one of my scientist coworkers told me, hey, but that's fine, but can you do it with R? And I initially said, oh yeah, of course, it's so simple, right? There's got to be a build pack out there and there was none. So that took a lot of talking to the community. I reached out to the Cloud Native Build Pack community in Slack, and they helped me. We hacked around for a couple of days. It turns out that you can use the Heroku builder with like a specific, you can just basically use a very specific Heroku builder that is meant to be used only in Heroku website. But if you just simply like add a single line, like a parameter to the CLI of Buildpack, you can then use it with Cloud Native Buildpacks. You don't have to be in Heroku. So that was great. I mean, I love Heroku, but we don't have it in our stack, and so it's very powerful. So then you have the detection, then you do analysis, and in the analysis stage, you check if there's some kind of cache that you can reuse. So this accelerates CI/CD. And then you have a build stage, which basically creates a runnable artifacts, and export creates a final OSI compliant image. So this is, well, I mean, I'm very sad that I cannot show you this in real life, but anyways, this is what is transforming, making the journey of our data scientists like simpler. And then of course I wanted to show from here that if you go to the next slide, it's going to be like KServe in one picture, because I didn't have time to go through like all details of Knative, cloud native Buildpacks, and then everything about KServe. But like I mentioned, KServe, for those who have not used it, and it sounds interesting because not everybody uses KServe in our company, because not everybody needs like an endpoint. Most you can have batch processing, and then just running a pipeline is enough. So that is something that maybe not everybody in this call might be familiar with, but if not, there you go. You have some computing infrastructure, you have Kubernetes, and then of course on top you could have Knative, and if you have it, then you have serverless, and it's great. And at the top it's KServe, and I feel like the all the features that we have, like the explainers, are just massive in terms of making sure that you have a new version. What I was going to show you is that you can create a prediction, and then you can see the logs and really determine if version 2 of the machine learning model is slower than the previous version, and then you can decide if that's important or not to roll back. You can have a pre-processing. So in this large language model era, you can have a pre-processing pod that is running on CPU, that is cheap, and then maybe only the inference is done in GPU, or vice versa, depending on what's best for you. So you can have a pre-processing pod that scales independently, a predict pod, a post-processing pod, and so it's just very flexible. And I think that we're just like on the getting the benefits of KServe like little by little, and I'm very excited to see what's next. I see that KServe is in the future trying to look into asynchronous inference services, like kind of out of the box. So really looking forward also for what's to come there. If you go to the next slide, I hope you will laugh, because that was that was my demo time, which I can like now wipe the sweat. I don't have to do a demo, although I'm very sad that I don't have to do a demo. And if you go to the next slide, then I will show you the necessary company slogan at the end of each talk. But most importantly, if you go again to the next slide, you can see some of the references that I used. Like I said, there's lots of very good references already, lots of books. O'Reilly has like 90% of them, I guess. But yeah, just check them out. And also you can reach out to me on LinkedIn. I try to like share things that are interesting for like MLOps world. I usually republish more than publish, but maybe that might change. So you can just follow me by like finding me on Oswaldo Gomez in Roche, and I should be there. I sadly have to pass back the microphone because I was going to present here my screen, but it does not work. But I wanted to thank you for the chance of letting me speak, and yeah, really thankful to the organizers, and hopefully next time I can go there live, so minimize the risk of something happening. And thank you very much.
Oswaldo, thank you so much for your talk and for helping us through our little technical difficulties.
I cannot hear anybody, so if anybody's still there, I hope you like the talk. I think you're muted, Dallas, and
can you hear me now?
Yeah, I can hear you.
Got a little bit of an echo for some reason. Probably my computer.
I mean, I think the name of the Zoom person is Dallas. I know you're in Irving, Texas, but yeah, it was very nice to talk today.